Good morning. Welcome to the session of Instrumentation Engineering. Today our discussion topic is Introduction with Basic PLC. So if we talk about PLC, it is a very popular name to all of us in the control domain. If we just try to get the idea about this PLC, the full form of this PLC is Programmable Logic Controller. So if we just try to get the idea about the PLC from its name, that means from this controller, we can go through any type of programming. So mostly all type of programming can be done by this control approach. Also, if you want to give the logic in this particular controller, that also can be possible. That means not only the continuous control, different types of discrete control can also be possible using this PLC. So programmable logic controller or PLC is consisting in the industry for last few decades, and they are establishing its position into the industry because of the different purposes and different uses of this particular controller. Now, if we just try to get the definition of the programmable logic controllers, which is defined by National Electric Manufacturer Association, which is known as NEMA, in the year of 1978, the statement will look like this: a digitally operating electronic apparatus which uses a programming memory for the internal storage of instruction for implementing specific function such as logic, sequencing, timing, counting, and arithmetic to control through the digital and analog modules, various types of machines or process. That means it is nothing but a digitally operating electronic apparatus through which different types of function can be implemented, such as logic operation, sequencing operation, timing operation, counting operation, and arithmetic operations. And not only that, here it is associated with the digital operation, means the processor, the memory, the input, the output, all the modules are associated with these programmable logic controllers. So that's why this programmable logic controller is consisting with different parts of the system through which it's able to give us a good output in the control system. Some of the leading brands of PLC who are manufacturer in the different regions of world are the Allen Bradley, Texas Instruments, Westinghouse, Carter Hammer, Squad D. They are from the American. The European side, the leading brands of the PLC manufacturers are Siemens, Festo, Telemechanic. They are the leading brands. Not only that, also some of the Japanese companies also making these PLCs, or they are the leading manufacturers in the world basis. They are the Toshiba, Omron, and the Mitsubishi. So these are the leading brands who are working for the PLC for last few decades, and this PLC is upgrading day by day of its uses, of its benefits, and of its operations. So obviously these are the leading manufacturers or the leading brands which we need to know when we just try to go for the PLC discussion. Obviously this PLC is defined by its size. That means how much input or output module can be handled by the PLC. That means if we talk about the small PLC, it covers units with up to 128 IOs and memory up to 2 kilobytes. That means if you are purchasing from one of the leading brand and you are purchasing a small PLC, we call it a PLC as a small one if it can handles up to 128 IOs, input output modules. Already I talk about the tag numbers and the loop numbers in the time of discussion of PNI PNI diagram. So in that time I already told you that the IOs or the tag is very important over here. So the small PLC can handle 128 number of tags or 128 number of IOs, whereas the memory capability is 2 kilobytes. So these PLCs are capable for providing the simple to advanced levels of machine control. So if your plant is very small and you are requiring near about 100 of IOs over there, so in that cases, obviously you can purchase the small PLC for that particular system. Now, if we just go for the medium one, so obviously the number of IOs will be increased over here. This is 2048 IOs can be handled, and obviously the 2048 IOs you are handling, so the memory capability need to be increased with this 32 kilobyte of memory capability is there. Now the large one, that means which can be used for an entire plant or an entire production unit. Here the total number of IOs can be handled is 8192 of IOs can be handled, and obviously if you are handling 8192 IOs, that means the memory capability need to be increased, which is 750 kilobyte. So in this way we are defining the three types of PLC according to their sizes. One is known as small, another known as medium, and another known as large PLCs. Now this slide is very important for the discussion of the PLC. Now it is the major component of a common PLC. If you want to know, as I already mentioned to you, here the digital control is occurred, so obviously the processor will be required over here. And if you have a processor, so obviously power supply will be required. So the power supply and processor is obviously consisting with your PLC. But not only that, as the name suggests, it's programmable logic controller. So obviously the logic need to be given to the user end by a programming device. So the programming device also will be there. So using this programming device, we can give the information to the PLC. Mostly in India, we are using the ladder logic, through which we are giving the logic to the processor, and the processor can understand that which type of logic we are trying to implement, and according to our logic it acts. Now if the input we have taken from the field instruments, so mostly the field instruments input are in the analog type, that means 4 to 20 milliamps or 1 to 5 volt. But because the processor is associated, because the digital control is associated over here, so the input module, which is known as a sensing module, it will take a vital role over here. That means it will takes the advantage at that particular point, that whatever the analog input you are giving to the input module, it will transform it to the digital one. That means it is nothing but the input module is consisting with the ADC, analog to digital converter, and the output module, which is also known as a control module. So in this particular output module, again the output or the control output need to be given to the final control element. So in that case, again the output module takes a vital role, in which the processor giving the output to the output module as digital one, and the output module makes this digital output to the analog one and send it to the final control elements. Maybe that can be a control valve, maybe that can be a solenoid, maybe that can be a contact, maybe that can be an alarm. So in that particular case, we can say the input module is, or the sensing module is acting as a analog to digital converter, whereas the output module is acting as a analog to digital, the digital to analog converter. So in that way, the sense, logic and control can be happen into the PLC. Now one of the example, if we just take that we have a processor over here, which is obviously a digital control, and the input and output module will be there. We have a temperature control module in the field, and from there we are taking the input in the form of a range of temperature 0 to 100 degrees centigrade with the voltage range of 0 to 10 volt. That means at 0 degree centigrade temperature, nearly 0 volt we are getting. At 100 degrees centigrade temperature, we are getting the 10 volt of output. So now it is very obvious that whenever it will come to the input module of the PLC, it need to be converted into the digital one. So now how the conversion will be done, and one of the most vital part of the PLC in the discussion is the sampling frequency and the resolution. So if the 5 volt we are giving, in that particular case, if my processor is a 8-bit processor, so in that case my ADC or the input module get the information for each lowest measuring value will be 5 divided by 256. That means 2 to the power 8 means 256. If we go for it, then the 5 by 256, that means a precise measurement of 0.019 volt of measurement can be done if the change will be happen into the field. Now if we just try to get some more precision into the processor level, then we can go for the 10-bit. So again the resolution can be higher and the lowest measuring value here, then again low from the 8 bit, it is 0.004 volt for each change of that very low value of 0.004 volt. If you go for 12 volt, again the value will be again low, it is 0.001 volt. So if you go for 8 bits, so obviously a precision will be there in your measurement. Again, if you go for 10 bit, then more and more precision you are getting. If you go for 12, if you go for 16, if you go for 16, then a very much small change of 0.000076 volt, that can also be considered. So it is a very vital part, how much resolution is required to your industry. As per that requirement, you can choose that which type of processor you want to use. It can be a 8 bit, it can be a 10 bit, it can be a 12 bit, it can be a 16 bit. If you go for more and more bit of processor, so obviously more and more accuracy you can get it from the field, that a very low value change in the voltage, then that also can be addressed by the processor unit and the processing unit. So this resolution in the PLC takes a very vital role, which we need to consider into our discussion. Not only that, the sampling frequencies and another approach which we need to again consider when we talk about the PLC is that how fast the field instrument give you the information and how quickly you are taking the information to the processor. So if there will be any mismatch to the field instrument to the processor unit, then the lag will be there in the information interchange. So in that particular case, if the information interchange is not happened with the similar speed, then obviously we can say there will be mismatch, there will be delay, there will be a lag. So the sampling frequency need to be adjusted for the processor as well as all the field instrument through which the information we are taking into our consideration for control. So that need to be addressed for each and every cases. So as I already mentioned to you that the resolution and the sampling frequency, there takes the vital role into the PLC. So we can't take it into a minor way, that whatever the resolution we can take, whatever the sampling frequency we can take. But one thing you can take it into your mind, that if you want to change from 8 bit to the 10 bit, then lakhs of rupees you need to invest to get that particular processor. So if it is required that much of precision, that much of precision control for your output, then obviously you can go for a higher bit of processor. If it will be not required, then 8 bit is enough to use for the PLC in regular users. Now here the major components, what I already discussed to you, the information is given with the statement, we try to get the knowledge about it, that the major components of a common PLC is power supply, obviously it will be required, provides the voltage needed to run the primary PLC component, so no need to discuss about this particular fact. After that, the IO modules, which I already told you, provide signal conversion and isolation between the internal logic level signal inside the PLC and the field high level signal. So which I already mentioned to you that the most of the cases the field signal we are getting in a higher side of voltage and current. So obviously we don't want to hamper our processor. So in that case the isolation will be required. In that case obviously the conversion from voltage from analog to digital will be required over there. So that we need to take under the consideration by these IO modules. Now the processor, which is the master brain of your PLC, provides the intelligence to command and govern the activities of the entire PLC system. So it is the mastermind of your PLC through which the processing can be done. Whatever the information you are giving to the processor, that will be taken care at that particular unit. Programming device used to enter the desired program that will determine the sequencing of operation and control of process equipment or driven machines. So obviously the input will be given through the programming device. As I already mentioned to you, in India most of the cases we are using the ladder logic. So using the ladder logic we try to give the sequence of operations. We can give the logic over there, that in which time which type of logic need to be implemented, what is the sequence of the implementation of the control, and all the things can be given to the processing unit by the programming device. IO module, the IO interface section of a PLC connects it to the external device. So as I already mentioned to you, the IO module will make the connectivity between the external field device. The main purpose of the IO interface is to condition the various signal received and or sent to the external input and output device. So it is already, I told you that the input module and the output module takes a vital role in which analog to digital conversion can be taken, and also the isolation can be taken for the input module, whereas in the output module again the isolation and from digital to analog conversion is happened and it will go to the final control element. Input modules convert the signal from discrete or analog input device to the logic level acceptable to the PLC processor. Already I told you for many times, output modules convert the signal from the processor levels capable for driving connected discrete or analog output device. So IO is nothing but acted as a ADC, whereas output module is acted as a DAC. Now, what are the components we need to address for the IO module that will be given over here? First of all, because of the very high voltage and current provided from the field instruments, we need to use the current limiting resistor. So the purpose of this current limiting resistor we can use is that used to drop the voltage to the logic level first, because the processor is working with a very small amount of voltage and current. If large amount of current and voltage can be going through the processing unit, so then the entire process can be hampered or entire process can be damaged. So first of all, the current limiting resistor make the restriction of to drop down the voltage to a logic level. After that, there will be no connection of the processor to the IO unit. So here we are using the opto isolator, which is a non-connecting conversion of a voltage from analog to digital one. So here it is prevents the voltage transient from damaging the processor, help reduce the effect of electrical noise. So opto isolator make a very well established approach at that particular area, that it will separate the entire process to the IO modules. So that will be very beneficial to us at that particular part. After that, the buffer filter circuit will be there, through which the information or the input will go to the processor unit. So there will be a three parts through which the input from the output device that will come to the IO unit of your PLC, then it need to be go through the current limiting resistor, it need to be go through the opto isolator, then it can be get the chance to go for the processing unit. Similarly, in the AC module, it will consisting with the rectifier resistor network. Again, it will convert the AC input to the DC, drop to the voltage to the logic level. After that, the similar approach will be there for the AC input modules. If the input signal which is coming from the field, if that will be the AC, then the rectifier and the resistance network will be required at that particular end. Now, if you will go for the output module, here from the processor, the output will first go to the TTL, the transistor logic circuit. Here three transistor configuration mostly used, and here these three configuration try to make the signal of the output into a one output of the signal. After that, again the opto isolator is used to make the isolation between the processor unit and the output device. After that, the amplifier or the relay, or we can say the coil will be there who will be energized, through which the output will be given to the final control elements. So it is again the part of the IO modules through which the output from the processor will go to at last to the output device or the final control elements. Some of the inputs which we need to know, through which we can give the inputs to the PLC, is that push buttons, open switch, close switch, and open contact and close contact. So as I already mentioned to you, in our India, we are using the ladder logic. So most of the cases we are using the contacts over there, which is known as normally open contact and normally close contact, through which the input can be given. Also, not only that, we have the option of push button, we have the option of close the push button for the energize of the different types of motors, different types of machines. We have the option of switches which can be used for the PLC inputs. obviously in the discrete way. And also, as I already mentioned to you, most of the cases in ladder logic, we are using the open contact and close contact concept, which is the logic 0 and logic 1 concept. So PLC operation, the basic function of a typical PLC, again, if we just jot down all the information over here, it read all the field input device via the input interfaces, execute the user program stored into the application memory, then based on whatever the control scheme has been programmed by the user, turn the field output device on or off, or perform whatever control is necessary for the process application. So it is a very good statement, we can say, through which the entire process of PLC can be understood to all of us, in which we first read all the information. After that, it will interface to the IO modules. The IO modules will give the information to the processor. Processor already taken the information from the programming device that what action need to be taken for what type of input. Then the action will be taken. Then the action will be executed to the output module, and from the output module it will go to the final control elements. I need to switch on my motor, or I need to switch off my motor. What position of the control valve need to be take care right now. So all the information can be given from the IO unit. This process of sequential reading of the inputs, executing the program in memory and update the output is known as scanning. So a very good information is given at the end, that the sequentially reading the inputs first, which is coming from the field instrument, executing the program in memory, and updating the output into the output side, and it will go to the final control element. So the entire process is known as scanning operation of PLC. So what are the phases we need to go for a PLC operation that will be represented over here? So first phase will read the input and scan it, which will be the action of IO module. The phase 2 will be the program execution. This is nothing but the area of the processor unit in which the program which are already given by the user end of the programming device, using the programming device, that will be executed first. Phase 3, we need to diagnostically try to understand that what is the action right now in our input and what corresponding action need to be taken over there. So that phase needs to be taken care at phase 3. And if it will complete it, then we'll go for phase 4, which will be the output. That output will be scanned at the output unit, and after that it will go to the final control element. And again, the same circle will go from phase 1 to phase 4 simultaneously. Selection of a PLC, what are the criteria we need to take under our consideration when we are selecting a PLC? First of all, number of logical inputs and output. In the initial discussion, I told you that we have 3 sizes of PLCs: small, medium, and large. So whatever the input and outputs you have in your practical industry, then you need to find out, as per the input and output, which type of PLC is required. It will require a small one, medium one, or a large one. Obviously, as per the input, the memory need to be taken care over there. Number of special IO modules. If you have some special IOs for the safety purposes, for the different purposes you want to use some of the IOs, that also need to be under the consideration, because topmost IO that can be handled for a small PLC, that is defined, for a medium PLC that also defined, for a higher PLC that also defined. So that also need to be taken under the consideration. Scan time, as I already mentioned to you, the sequencing operation, the sampling frequency, that is also an important point. Communication, how the communication is done, that is also a point. Resolution also need to be included over here, and which type of software we are using, that is also takes a vital role over here for the selection of a PLC. A detailed design process will start from understand the process first. We need to understand that which type of process we want, in which type of process we want to implement the PLC. Hardware and the software selection, which part we want to take in a hardware side, and how the connection between the hardware and software can be done. Develop the ladder logic, as I already mentioned to you for the many times, that the programming device, in the programming device, the user will take the advantage of a ladder logic to give the logic to the processor unit. So you need to develop the ladder logic. Determine scan times and memory requirements. So how much scan time will be there? What are the memory requirements that also need to be under the consideration? One of the important part of the ladder logic is that we need to use these normally open and normally closed switches, or contacts is better to say. If at the initial stage you are using the normally open, then it will take as state 0. After that, or contact 0, after that, whenever you make this NO to the contact 1 or logic 1, in that time this NO will act as NC, normally closed. Similarly, the reverse operation will happen that at initial stage when logic 0 is considered, in that time if you take the consideration of normally closed, so current can easily pass through it because your contact is closed right now. But whenever you make it the contact 1 or logic 1, in that time again the contact will change. The NC, or the normally closed, will go for the operation of normally open. So that need to be considered at the time of the developing of ladder logic. Coils are the output part of the ladder logic, in which if the logic is happened and if your output is getting at the output side of your PLC, then even if the small amount of current will be there at your coil, the coil will be energized. And if the coil will be energized, then we will get the output at our end. If take it the example in that way, that if the coil will be energized, then only my motor will start, otherwise the motor will stop. So in that case, I can take some contacts over there. I can play with the contacts, that in which time, in which logic, in which time the motor will start. So that can be possible by using this coil. So it is nothing but a switch, we can say, which will charge up whenever the output will be required. These boxes will be consisting into the ladder logic, which is giving the information about the timer, which is giving the information about the counter, and different various purposes, and the instruction can be followed using these boxes. So it is also can be implemented into the ladder logic in most of the cases. In a bottling plant, if you want to count how much bottle is passed through a conveyor belt, in that particular time a counter can be added into the ladder logic. Similarly, if the time is a foundation, that much time my motor will switch it on, after that my motor will switch it off. So in that, the timer can be acted through this box into the ladder logic, and we'll get the information about it, and according to this timer the operation will happen. Here one of the example we have taken, which is a NOT operation. So we know that for the NOT operation, if 0 logic we have given, we need to get the output 1. So here we have taken at the initial stage of NC contact, it is normally closed. So from the left hand side, if this is the current supply side, which is the left hand side, the current will try to pass. Here the contact is closed right now, so easily my current can pass through it and energized my coil. That means the logic of A right now is 0. I am not changing the logic, it is the initial state. So here the logic is 0, but I am getting the output, which is 1. After that, whenever I will make this A 1, that means energized or change the contact, so in that time this NC will act as NO. So current wants to pass through it, but here the open contact will be there, so current is not able to pass. So here the logic is 1, but my coil is not energized, that means I am not getting any type of output, that means output 0. So when it is 0, I am getting the output 1. When it is 1, I am getting the output 0. That means it is very much maintaining the rule of NOT operation. So that means this is nothing but a type of ladder logic we can make for different types of operation. One of the operation is provided over here, which is the NOT operation. What are the areas of application of PLC? Mostly in all over the industries, the PLC is very much appreciated. Without the PLC, not even a single industry can run. So mostly the area of the application are manufacturing or the machine areas, food or beverage areas, metals, power, mining, petrochemicals, and chemical industry. So mostly all the industries are using this PLC, programmable logic controller, to control the entire plants. That's all for today. We'll meet into the next session of different discussion of the instrumentation engineering. Thank you.